My name is Reinhard Budich, and I'm working at the Max Planck Institute for Meteorology in Hamburg, Germany. My background is in oceanography. I've been a modeler before, basically, and turned into a computer specialist, let's say, maybe scientist in recent years. At Max Planck, we do basic research, we do curiosity-driven research on climate. For this, we use climate models, so we basically do scientific computing, and we apply not only climate science but computational science in our daily work, so to speak. My role now in the institute is to care about scientific and IT strategic partnerships, basically. So I try to link the institute to the rest of the world in terms of what is going on. The European Network for Earth System Modeling is a network of about 50 European institutions that tries to deal with the intellectual and scientific and computational problems of climate modeling, basically climate and Earth system modeling, I should say. It's a platform for exchange on these topics. I think it has a record now in terms of making people know to each other and steering interaction on these topics, and as such trying to make the institutions involved a little bit more efficient in applying the most modern methods in this field, basically. So I think we are quite good in providing such a platform, and are quite happy that there is some engagement by the community, but it could be more. These two key drivers I was mentioning in my presentation, namely science and society, are obviously very much intertwined. Science has left a lot of work to be done, basically, in terms of explaining the climate and explaining climate change. If you look back at the very long records, there's not a lot of models that can kind of hindcast the development of long-term climate and at the same time forecast the climate as it is today. So that is one thing. There's obviously a lot of feedback processes which we are still missing in the climate models and such. So there's a lot of unsolved science questions, I think, which are of interest not only to the scientific community but also to society, because society today relies basically on the fast and timely information about the climate change and about the changes that can be expected with the different scenarios that are possible for future of mankind, basically. So I think the societal need is very important for us, but also there's a purely scientific approach to the climate problem, basically, which we shouldn't forget. I think the community at large has the problem that so far performance improvements in terms of technical performance was coming by itself. So it was, as it was said in the conference here, there was some free lunch, and the free lunch is over. You really have to work very hard on your codes to gain performance efficiency and to make your code perform better in a technical sense, also in a scientific sense, obviously. But the technical sense sees the problem that there's not a lot of young people who are interested in learning computational sciences and applying that in our field. So I see a certain demand for young people being involved in our field, and that means that the single institutions do not have enough people, and that again means that there's not a lot of, or not sufficient engagement of these people in the community to make sure that the community does not compete on the infrastructure that we have, but they compete on the scientific content, which is obviously necessary. I think to remedy the situation, I think we need to invest into education much more as a community than we did before, and I know that some programs are there, but I think we could do more on that.